In the next set of examples, it says determine the maximum number of possible relative extrema for each polynomial function and state the end behavior of the curve. So your relative extrema, remember, are your turning points. The maximum number is the highest degree minus 1. So the maximum number of turning points for this one is going to be 4. It is an odd degree polynomial that is positive. If it's positive, that means as x gets big, the right-hand side, y goes up, so y gets big. Since it's odd, that means my left-hand side has to go in the opposite direction. And number 5, my maximum number of turning points is going to be 3, one less than my highest degree. I'm an even degree polynomial, but my leading coefficient is odd. So as x approaches positive infinity on the right-hand side, because it's a negative leading coefficient, I'm going to go down. And because it's an even degree polynomial, my left-hand side has to go in the same direction as my right-hand side. And number 6, my maximum number of turning points is going to be one less than my highest degree, so 10. As x gets big, because it is an odd degree that is negative, my right-hand side has to go down. Since it's odd degree, that means my left-hand side has to go in the opposite direction. In the next set of examples, you are going to factor the polynomial and then identify its roots and their multiplicities along with the end behavior in order to sketch the graph without the use of a calculator. So we're going to start by factoring out a 3x. So this is 3x times x squared minus 5x plus 6. So then this factors into 3x times x times x minus 2 times x minus 3. So when we set this equal to 0 and solve, that means x is equal to 0, 2, and 3, all with a multiplicity of 1. So I have 0, 2, and 3. I'm an odd degree positive polynomial, so my right-hand side goes up and my left-hand side goes down. So as x goes to infinity, y goes to infinity. And as x goes to negative infinity, y goes to negative infinity. So I'm going to come up and cross, come back down and cross, come back up and cross. And the next one, if I factor out a negative 2x squared, then this becomes 2x squared plus 3x minus 20. So when you factor this, this becomes negative 2x squared times x plus 4 times 2x minus 5. You set this equal to 0, and x is going to be equal to 0 with a multiplicity of 2, negative 4, and 5 halves. So I'm at 0, negative 4, and 5 halves, which is 2.5. I'm a even degree negative polynomial. So that means as x gets big, my right-hand side has to go down. And because I'm even degree, that means my left-hand side has to go in the same direction. So as x goes to negative infinity, y goes to negative infinity as well. So I'm going to come up and cross. I'm going to come over and bounce and then come back down. On the right-hand side, you're determining a possible equation again in factored form given the graph. So identify your zeros and write your equation in factored form. So this is f of x is equal to, my right-hand side is going down. So that means I have to be negative. I have x cubed because of my behavior here at 0. I have x minus 2 because of my behavior here at 2. And I have x plus 3/2 because of my behavior here at negative 1.5. But it's going to be 2x plus 3. Same thing in the next one. Identify your zeros. And we have f of x is equal to, my right-hand side goes up, so it's positive. And I'm going to have x minus 3 squared. This is 1/2, so it'll be x minus 1/2, or 2x minus 1 squared, times x plus 3 squared. In number 11, it says write a possible equation for a polynomial with a degree of 6 and having 5 as a triple root, -2 as a double root, and 3 as a single root. So this would be f of x is equal to x minus 5 as a triple root, x plus 2 as a double root, and x minus 3 as a single root. In number 12, you're going to find all of the zeros by factoring. So I start by factoring out an x. So this is x times x to the 4th minus 37x squared plus 36. And when you factor, this becomes x times x squared minus 1 times x squared minus 36. Well, this is a difference of squares. So this is x times x plus 1 times x minus 1 times x plus 6 times x minus 6. And you set all that equal to 0. So this becomes x is equal to -6, -1, 0, 1, and 6. In the last example, this is an application problem. So we have an open box is to be made from a square piece of material 36 inches on a side. By cutting equal squares with sides of length x out of each corner and turning up the sides. Verify that the volume of the box is given by the function x times 36 minus 2x squared. Show your work and mark the diagram. So I know that this is, the side length is going to be 36 minus 2x. And if we're working with a square, then that means the other side length has to be 36 minus 2x. And to find volume, you multiply length times width times height. Well, in our case, we have side times height. Well, the height of our box when I fold up this corner is going to be x. So my volume is equal to 36 minus 2x times 36 minus 2x times x, side times height. And when you simplify that, this is x times 36 minus 2x squared. Then it says, determine the domain of the function within the constraints of the problem. So your domain can't be infinite, even though this is a cubic function. The reason it can't be infinite is because I can't cut a square of side length 0 out of the corner. I can cut a square of side length greater than 0, but not 0. So x has to be greater than 0. But then we also have to take it in context of, well, how big of a square could I possibly cut and still have a box? Well, in this case, if I actually cut a square of 18 inches on each side, well, that's going to completely cut the square into 4 pieces, and I won't have anything to fold up. So 0 has to be less than x, but x also has to be less than 18. And then it says use a graphing utility to graph the volume and use the graph to estimate the value of x for which v of x is a maximum. What are the resulting dimensions of the box and what is the maximum volume? So when you graph this, you're going to find that the volume is equal to 3,456 inches cubed. And this is going to occur at x equals 6 inches. When you graph it, this is going to be a cubic function. Okay, it's going to be a cubic function, so it's going to behave like this. And you're going to have this maximum value. That maximum value is going to have the ordered pair 6 times and 3,456 as your y value. So in order to determine, this is the height of my box. So remember, side times height. The height of my box is 6 inches. Well, each side, when I substitute that into my side length, 36 minus 2x, so my side is 36 minus 2 times 6. So my side is equal to 24 inches. So the dimensions of my box that give me my maximum volume is 24 by 24 by 6 inches.